You can also solve the integration problem by using the Simpson's 3/8 rule. To apply this method, you need 4 points or 3 segments. Let the first point to be x0, second point here to be x1, third point to be x2, last point to be x3. So these are the 4 points here, and then you can form 1, 2, 3 segments. The height for the first point is fx0, second point is fx1, and if you continue, the last point is fx3. To find the integration for the fx function from limit a to b here, you can approximate it by using the Simpson's 3/8 rule, which is approximate the height function here by using the third order method. So you integrate from the first point, which is x0, and then to the last point, x3. By substitute the third order polynomial for the f3x function, and then after you perform the derivation similar to the one that we show in the appendix, then you can obtain the integration result to be this answer. Since we know the delta x equal to this formula, b and a is equal to x3 and x0 respectively, n is 3 segments, 1, 2, 3 here. Therefore, if I substitute this inside, then you should be able to obtain this formula, where you have the integration equal to the total width, which is here, multiplied with the average height from this function, which is over here. Similar to the Simpson's 1/3 rule, for the Simpson's 3/8 rule, you have the 3/8 coefficient here. Let's try to solve this by using the Simpson's 3/8 rule. So you have one function, you want to integrate it from a to b, and then for the Simpson's 3/8 rule, you need 4 points on this function, which form 3 segments. So in this case, the n is equal to 3, so you can use this formula to obtain the delta x. b and a is 0.8 and 0. Substitute inside, you obtain 0.8 divided by 3, then you obtain the delta x. So for the first point, x0 is equal to 0. For the second point here, x1 is equal to 0.8 divided by 3. Third point here, x2 equal to 2 multiplied 0.8 divided with 3. Last point is x3, which is equal to 3 multiplied with 0.8 divided with 3. So you obtain 0.8. Substitute these 4 points inside this function, then you can obtain the corresponding fx function. So this is your fx0, fx1, fx2, and fx3. There is a correction here. This will be x3. Substitute all the functions from fx0, fx1 until fx3 here by using this information. And then substitute the b and a from here. Then you can obtain the integration result to be 1.51. Compare this result with the actual result. You obtain the relative error to be this answer, and the true percent relative error to be this. By comparing with the previous result obtained by the trapezoidal rule and the Simpson's 1/3 rule, Simpson's 3/8 rule has the most accurate result because it has the lowest error. This is because Simpson's 3/8 rule is using the third order approximation method, compared to the Simpson's 1/3 using the second order, and trapezoidal rule is using the first order method. By increasing the order of the integration method, the error will be reduced, so you can obtain more accurate results. So far we have discussed the single and multiple application for the Simpson's 1/3 rule. To apply this method, you need to ensure that the total number of data must be equal to odd number. You need at least 3 points for the single application of this method. The number of segments required in this method is even number. On the other hand, you can apply the single application Simpson's 3/8 rule by using at least 4 data. So far our discussion is using a constant step size, which is delta x equal to b minus a divided by n. Therefore, you should be able to obtain equally spaced data for both of the cases. How if you have total number of points, which is n plus 1 greater than 4 points, and it is equal to even number? For example, if you have the total number of points equal to 6, 8, 10, and so on, in this case, which method should you use to solve the integration? If you have even number of points, which is n plus 1 greater than 4, such as n plus 1 equal to 6, 8, and so on, then you should have the segment equal to odd number. For example, in this case, you have 1, 2, 3, 4, 5, 6. You have total 6 points, which is even number. So the total number of points n plus 1 is equal to 6. Therefore, number of segments is equal to 5. So you can see you have 1, 2, 3, 4, 5 segments here. To solve this problem, we can use the strip method or the trapezoidal method. However, these two methods has low order. Therefore, the accuracy of the integration will be low as well. Let's try with the Simpson's 1/3 rule. So you need 2 segments for single application, 2 segments here for multiple application, and then you have 1 remaining segment here cannot be solved. So we can solve it by using the Simpson's 1/3 rule alone. In this case, we need to combine multiple integration methods in order to solve it, and it is called conjunction. So you can solve these 4 segments here by using the Simpson's 1/3 rule, and then solve the last segment by using the trapezoidal rule. So in this case, you have the conjunction between the 1/3 rule plus the trapezoidal rule. Besides this conjunction, we can also solve the first 2 segments by using the 1/3 rule, and then solve the next 3 segments by using the 3/8 rule. Simpson's 1/3 rule plus the 3/8 rule has better accuracy compared to this combination. This is because this rule involves higher order compared to this method. Let's solve this example by using the conjunction of Simpson's 1/3 and 3/8 rule. To implement this method, we need the total number of points, which is the n plus 1 equal to 6 and above. Let's choose n plus 1 equal to 6 here. So in this case, you obtain the number of segments equal to 5, and the first 2 segments is solved by using the 1/3 rule, and the next 3 segments will be solved by 3/8 rule. So let's find the step size from this formula. B minus A equal to 0.8. Number of segments n is equal to 5. Therefore, you obtain it to be 0.16. So you have point from 0 to 0.8, and the step size is 0.16. So the first point here is 0. So this is x0. So for the second point, x1 is equal to 0.16. 0 plus the step size, you obtain this answer, and your x2 is equal to 0.16 plus the step size, you obtain 0.32. Then you can continue for the x3, x4, and x5. And you should obtain the x5 equal to 0.8. Substitute x0 until x5 here into this formula to obtain the fx0, fx1, fx2, fx3, and so on until fx5. The first 3 points will be used by the Simpson's 1/3 rule to find the integration. And the next 4 points will be used to solve the integration by using the Simpson's 3/8 rule. Substitute the first 3 points to the first formula. B minus A is not from here, but is from these 3 points, which is x2 minus x0, give you 0.32. So the first point you substitute here is equal to 0.2 when your x is equal to 0. And the third point you substitute here, which is equal to 1.74. Since you only have 3 points here, therefore n is equal to 2 here. 2 minus 1 give you 1. And over here, you have 2 minus 2, you obtain 0. So you don't need to perform this term, and you need to perform this. So substitute I equal to 1 inside, you obtain the fx1. So fx1 is equal to 1.29. So substitute here, you obtain 4 multiplied 1.29. So for this 3 point, you have 2 segments. So n is equal to 2. Substitute inside, you obtain 6 at the bottom. So you should obtain this parameter in this formula. And then after you perform the calculation, you should get the integration for the first 2 segments here. So in this case, you have a function fx. So you have 6 points. Now you have used the first 3 points to compute the area for 2 segments. We are going to continue for the next 3 segments by using the 4 points. And you see this point here is overlay for these 2 methods. When you apply the formula, you must understand the term here instead of directly apply it. Now you want to use the 3/8 rule formula to find the area within these 3 segments. So the width will be from the last point x5 to the x2, which is x5 minus x2. So you should have 0.8 minus with 0.32. Then you should obtain the answer to be 0.48 here. So this 4 point is referred to here. So you need to be careful. If you blindly use the formula without understand the term, then you might select this 4 point here. So if you select the first 4 points to compute the area region here, then this will be a mistake. So we shouldn't do this. So now your first point is here, which is x2, x3, x4 and x5. So we should change this symbol to avoid confusion. And then substitute all the data here inside. Then you should obtain this parameter. After you compute it, you should obtain the result for the integration. So you have successfully used the Simpson's 103 rule to obtain the area for these 2 segments, which is equal to this answer. And then you use the 3/8 rule to obtain the area under these 3 segments. And the answer is equal to this. So the total area is equal to the I1 plus I2, which is this answer. Therefore, this is the final result. When you compare the numerical result obtained by this conjunction with the actual result here, you obtain the relative error to be this and the true percent relative error to be this. So this error is very small. This is the lowest error that you obtain so far as compared to other integration methods. Therefore, we can say that the conjunction of the Simpson's 103 and 3/8 rule gives the best result in terms of the accuracy. In practical, when we say Simpson's rule, it can be Simpson's rule 103 or the Simpson's rule 3/8 or the combination of it. Although this method gives the most accurate result, however, is less commonly used in practical due to its programming difficulty. For example, like this case, you need to precisely determine the number of segments for the 103 rule as well as number of segments for the 3/8 rule. So you spend more computing effort on this. In actual, we always use the trapezoidal rule to solve the problem, despite of its low order issue. This is because trapezoidal rule is easy to program. It spends less computing effort and more flexibility, as this method can be applied to the total number of points to be odd or even number. and we can increase the accuracy by increase the number of segments. By doing this, the computational time will be increased. So this is the disadvantage for the trapezoidal rule. There are pros and cons for each method, and engineers need to select the best method suitable to their scenario. In terms of accuracy aspect, we will choose the Simpson's rule to solve the integration problem. If you want to choose the integration method that is suitable for most of the sample in terms of odd and even number with easy programming, then we can go for trapezoidal rule.